I'm Max. The guy in the back is Aaron, and we intend to talk about contemporary network configuration for Linux and why ifupdown-ng exists now. So, who are we? So you are about to start.
Yeah, I'm Aaron A. Glenn, only because there's an NFL player named Aaron Glenn. Network janitor, generally unpleasant internet working curmudgeon. If you want to, you can always tweet at me about reprogrammable networks. I imagine most people here have seen me tweet. Yeah, the usual contact stuff. Max?
Sure. I'm Max. Well, I'm not a janitor. I'm a landscape architect, but for technology and infrastructure, Debian fanboy, doing lots of stuff in this area, and recently have been pulled into this Network Services Association we will be talking about, and well, you can reach me there. So
yeah, just to give a little color background on why someone went ahead and made a whole new ifupdown next generation. This was spawned by an actual commercial engagement. From some field experience, we ended up with some strong opinions. We had a big opportunity for a large rollout with some strange financial and logistical constraints. And that ended up with us being handed kind of carte blanche. They had gone through 2 vendors, 6 months, and it wasn't going anywhere, failure after failure. What we had were some odd instruction set architectures, in this case MIP64, and of course with it a very ancient Linux kernel. What we needed was something a little more this century, this decade, maybe even a year or two old or more recent. We needed to handle complex configuration scenarios. If you consider PPPoE and GRE and things like that complex, that's what we needed to do. And we needed to avoid dependencies on interpreted languages or outside things. We needed something slimmer and more all-inclusive. So from those strong opinions, we decided to do some new code in this project that unfortunately didn't, due to COVID, didn't actually go to deployment. But from that, we ended up engaging the Alpine Linux project, putting that on MIP64, and really getting a taste for how to handle complex configurations out in the field with all kinds of interfaces. In this case, the deployment was in APAC, which is known for its wide variety and color of ISPs and configurations and situations. After it kind of proved itself there, we thought, well, where might this be useful? I'm big in the disaggregated networking scene, for whatever that means, and that means Linux. So we're also looking at taking this further than just configuring interfaces on host devices, but that's the tease. We'll get into the actual technical details with Maximilian, who's written quite a bit of the code. Max?
Okay, so then there was this network service Linux, which basically is pimped Alpine on a little steroids, and we are working on the steroid part. It has Musel, no classic libc, so no systemd in the picture. And what we wanted to add is a flexible and contemporary network configuration. By default, Alpine came with ifupdown-1, which is therefore, I think, 20-ish years for now. And from today's point of view, it's not that state of the art anymore. So we took a look around. What is out there? There is a classical IP route 2 for today's point of view. There also is all this old ancient ifconfig, netstat, whatever stuff around, but well, that's ancient. There are 2 flavors of ifupdown, the classical ifupdown-1 port, and for some years, I think there is ifupdown-2, which is written in Python, and from Cumulus. There are things like NetPlan from, I think, Ubuntu ships with it. There is NetworkManager, systemd networkd, the Red Hat universe has stuff, etc., etc. But nothing of this really felt like the way we wanted it. So we took a closer look in the ifupdown universe. As said, ifupdown-1, it's known from Debian and derivatives, used on Alpine for years. It's also part of BusyBox, so there is a stripped down version. It's written in C, but mostly monolithic. It can be extended through some shell script or whatever executables you could put into the classical directories, etc network D, if up D, if down D, or whatever, for all the states it runs through. But that's basically it. If up down 2 is a complete rewrite, which mostly is a drop-in replacement. I had some hands into that into the last years and added some stuff. They are quite open to pull requests. But it's in Python, so it needs a lot of dependencies. If you want to have small footprint with small devices, CPEs or whatever, that might not be what you want. But it's easy to extend and modular. So that sounds cool, but not what we really wanted. What do we want? We wanted something which is mostly a drop-in replacement. So it should be compatible with ifupdown 1 and 2, for that matter. But should in the same way support everything which is used today, VXLAN, VLAN and web bridges, VRFs, tunnels, etc., etc. Should be easy to extend because who knows what will come, and it should have a small footprint, as small as possible. And that we built. Today, Alpine and Debian are the primary supported environments we target. We have feature parity with ifupdown 1, so you could get the Debian packages, install it, and it should not fuck up your system. If it does, please open an issue. We have dependency resolution on top of it. So in ifupdown 1, the order of interfaces in the config file is relevant, and things will be configured from top to bottom. We stole the idea of dependency resolution from ifupdown 2, so the order does not matter, and we will figure out the best we can to set up the underlay, set up a bridge, or set up the physical interfaces, set up a bond or VLANs or a bridge and VXLAN on top of it. And today we are already included in Alpine 3.13, or will be, I'm not sure if that is released yet, and of course in Network Services Linux version 1. The plan is for the future to target other Linux distributions and become a native package in Debian, and maybe go for the BSD world as well. Of course, we want to add checking and reloading of network configuration like ifupdown 2 does. There is ifquery -- check, which will check the config versus reality and will complain about things that differ. And there is ifreload, which takes the config and makes reality fit to that. And probably we want to support netlink directly or go for netlink as a backend. So what do we do today? The core is written in C, which contains the config parser, which contains a compatibility layer, which I recently added to add some compatibility to ifupdown 2 to mangle stuff internally a little bit. It contains the dependency resolution, and that's basically it currently. There are executors, which are kind of add-ons, which do the heavy lifting. Currently, those are written in shell, but you can write them in whatever language you want. It's something which currently is executed from the C part and gets a lot of environment variables and then has to figure out what to do. They create, set up, tear down links, tunnels, whatever, and configure IPs. So there is, for example, a static executor which will configure IPs, set gateways, remove stuff. We kind of took over the phase concept from classical ifupdown, which has pre-up, up, post-up, and on if-down, pre-down, down, and post-down, we added a create phase to start with on the if-up state, if-up way, and we added a destroy phase after post-down. Currently, we built the dependency tree. All interfaces will be configured according to this dependency tree. Then we do create, pre-up, up, post-up, and then the next interface, which has some problems, so that might change in the future. As of today, we can do all this. As I come from the Freiform context, which is mesh networks, open mesh networks in Germany, We also have support for Batman Advanced, which is the better approach to mobile ad hoc networking, which is a Ethernet over Ethernet mesh thing. Maybe you don't have heard of it. I guess the rest is self-explanatory. So we can do quite a lot today. What about tomorrow? As I said, checking the running configuration and reloading it with minimum impact is on the roadmap. Phase-wise execution is, so the idea is to loop over the interfaces according to the dependencies for create phase, pre-up phase, up phase. So you can fiddle around with bridges, and after the bridge is there and the members are within the bridge, sorry, you can then configure the VLANs on bridge interfaces and stuff like that. So there are some circular dependencies when configuring or bringing stuff up. That might get easier if we have phase-wise execution. It's something I'm hacking on, so let's see when this will come. Another idea is to have native executors, which will be written in C, and we'll use netlink instead of calling IP route or whatever binaries to do the heavy lifting. Let's see how this goes. This will need some thinking, so we can do some IPC between the core and the executors and stuff, but it's on the roadmap. And the idea is to add support for setting static routes and policy-based routing rules on interfaces if you have some easy setups which don't require stuff like grip or OSPF, ISIS, BGP, but you want some simple static routes and don't want to fiddle around with post-up commands and stuff and have all this natively in the config. Of course, automated integration tests would be cool. That's something we want to do. So every new pull request on your release will go through a Docker container and run some tests and see if things break. And it would be cool to be, sorry, a native Debian package. What about next week? There are some visions. Managing Wi-Fi interfaces is on the roadmap too. It might be relevant for CPE devices and stuff to configure maybe an infrastructure network or an uplink. So to be a station in some uplink Wi-Fi and then do magic for out of band or whatever. And the idea is later on to hack a daemon, which will be started on startup and listens to netlink events and does the needful if interfaces are created, are removed, bringing them up maybe like something like UDEF, but for networking. And so we can tear down and bring up interfaces appropriately and have some event-driven network management, but not suck at it. So there's the code. Shortly, there will be a link for a APT repository with Debian packages. So you can play around with it. And if you have, if you want to discuss with us, come to our IRC, to the channel, or ask questions.